Hey, how are you guys doing today? I feel like I'm sitting after a long time. I do have a little cough, so it's not contagious, it's just little cough, allergy. So I was thinking of making a video of the lecture we did in our last class, which I forgot to record. And then I was like, instead of making a video, I can just go over the materials again quick, and then I don't have to make the video, and you guys will have a review also at the same time. Any question before you start? Any comments?
Originally, the second exam was going to be October 29. Is that still the case?
No, because we don't have much materials. We have, most likely we'll have our next exam on November, on the week of 17 or on the week of 24. One of them. November 17 or November 24, one of these days.
That last midterm or
Last, the second exam. And then we have our final exam, December somewhere. Our last year class is 15. So probably our exam will be 17, something like that. Not sure, I didn't see the final exam schedule yet. But yeah, it will be on the week of 15, I guess. If our last year class is 15, then most likely it will be 17 or 22. If I'm not wrong, 22 is too late. I don't think it will be 22. It will be before Christmas. Christmas, right? Yeah. Oh, I have a exam I'm going to give you later after a while. And I graded all of your homework. And one thing I noticed is that a few of you submitted the work, only the final answer without doing any work. So if you did that, only give me the answer without showing any work, I didn't give points. Even though I said homework is based on completion, I meant you have to complete fully, okay? What answer you have at the end, it doesn't matter. It could be wrong, it could be right. I'm not going to check that, but I want to see your work, the correct process of the work. In the correct process, the number could be wrong, okay? It doesn't mean you can do completely wrong something. For example, if I ask you to find, or if I ask you to get the solution using row echelon form, or Josh Jordan or whatever the thinking, REF or RREF, if you have to use those, but you didn't use them. Instead, you just did system of equations one by one, the way we learned in algebra classes. If you did that, there is no point because you didn't follow the direction. The direction says solve them using row echelon form or reduced echelon form, okay? So please follow the direction when you do the homework. Why I give you homework? Because we can't do practice in class. Our class is only 1 hour, 15 minutes. We cannot do many practice example here. So whatever we learn in class, in order to have you practice on those materials, I assign you the homework. So if you just cheat and then tell AI, hey, give me all the answers. I actually found a few of you. Just copy the answer from AI. And even whatever AI said, this graph is not clear, is not visible enough to give me the answer. They copied the exact same thing. Okay. So I can tell whether you use AI or you just did on your own. Please do not use AI. You can check your work if you want to, but do not copy and paste everything. Okay, it doesn't make sense. Also follow the direction, what the direction says. Whatever method they want you to solve using that method, please use that method, not any other method. And what else? Show all the work. Even though I'm not going to check every single work, but I want to see that you did your work, okay? So to reward you for your work, I give you the points. But if you don't even do any work and expect me to give you the full credit, you're wrong. I'm not that nice, okay? What else I noticed? Typing. Please do not give me typed answer sheet. I'm not a machine, okay? I'm a human being. I cannot read 1, 2, 3, comma, 4, 5, 6, comma, row wise, column wise. What is this? Do you expect me to read like a ChatGPT? I'm not ChatGPT, okay? I want to see 1, 2, 3, 4, 5, 6 written in a matrix format, not in row wise, not in column wise, okay? I get really angry, like, trust me, it was so hard for me to even understand what they wrote. Okay, if Maisha did that, I understand because someone else is doing it for her. So she can write anything, she can read anything. I understand. So I completely agree if she gives me a tight version. But except her, if anyone else gives me tight version, I'm going to give you 0 without even looking at the solution. I'm that angry, okay? But seriously, especially the review homework, it took me so long to grade them because I wasn't able to understand what you're trying to tell me. Because I'm a human being, I'm too used to seeing this format, not 1, 2, 3, comma, 4, 5, 6 format. Okay. ChatGPT understand that. AI understand that. I am not AI, I'm a human being. So don't expect me to get you points. If you submit typed version of your homework, any type of homework, if you do it typed version, it's automatically 0. I want you to write by hand. I want to see your handwriting. You can write on tablet, no problem. You can write on paper, no problem. But do not type. If you want to type, do like mine, okay? See, you can understand everything what I did here. I didn't write anything here. I typed everything. But you can understand everything. So if you want to give me type version, do it this way. Don't give me horizontally, vertically, those things. I do not understand them. Okay? You can already see like how angry I am. Sorry about that. Drinking some water. Because it is so frustrating, like okay. Anyway. About this class, I was actually happy that almost 20 of you got above 90 in the exam, which is amazing. And many of you got above 100. But unfortunately, the highest grade you can get is 100 in the exam. So I didn't give you anything more than 100. Even if you have 107 or 105, I still give you 100, okay? Because that's the highest you can earn in the exam. However, if you got more than 100, I transferred those points into your review homework. And not many people actually got that. Many people got above 90, not many people got above 100 and did better in the review. So if you got above 100, you got 100 in the review. Like I saw that already, you already have 100 in the review. So I have nothing to transfer. So for your case, you did great, good. There are a few of you actually got 100 on both quiz, not quiz, on review homework and also on the exam. Keep trying hard. And what else I have? There was something else I wanted to talk about, but I forgot. I'll tell you if I remember it.
So the lecture today is the same as, no, or you're just gonna review it more quickly? And you're gonna record?
Yes, it is recording. Sure.
And this Friday is online, right now, in person.
Yeah.
Oh.
But I was thinking of not having it this Friday.
Of what?
If I cancel the class, will it be too much trouble for you guys?
That's Friday.
Yeah, they made it to Monday schedule, and I actually have a family problem. So I was thinking of canceling the class. Can I cancel the class on Friday instead of being online? I'll finish the syllabus, okay? So don't worry about the syllabus. And I'm not going to hurry. I'll go slow, but I'll finish the syllabus, okay? So let's not have the class this Friday. Friday is a hard day for me. Okay, so we're going to meet again next week, Monday. And from Monday, there'll be usual classes. Monday, Wednesday, Monday, Wednesday, Monday, Wednesday. No more break, no more weird classes, no more weird days, okay? I'm glad. All these days are really hard to maintain, like when I have which class or which day I have which class, like so bad. It was so bad for me. Okay, anyway, so chapter 2, From chapter 2, we have only two sections to cover, 2.1 and 2.2. So you're going to do the homework to get that 2.1 and 2.2. Oh, I remember 1.5. So I assigned you section 1.5 homework. Did you notice that on Brightspace? Section 1.5 homework. So that homework also have some extra credit. So we have 13 points real, and then another 13 or 16 points, I forgot, is extra credit. So if you do extra credit, whatever you missed from before, you can cover those with 16 points. 16 points is a lot. Yeah, so that due date, I forgot, it's 28 or something, 29. Yeah, I think next week, Monday, 27, if I'm not wrong. So 1.5 homework due date is 27, Monday midnight. And then probably following week, we have 2.1, 2.2 homework. 2.1, 2.2, they don't have many homework, so we'll be fine. Okay, so matrix. We learned how to solve a matrix. Now this time we want to work with inverse matrix. Why do you care about inverse matrix? Because some equations, I mean, you already found that using reduced to echelon form is hard, or in the exam, almost 90% of you could not able to solve it. The reduced to echelon form question I had in the exam 1, 90% of you are not able to do it, even though it was actually a very easy one. Okay, I'll post the solution so you will see how easy it was. But for some reason, you guys were not able to do it. So for you guys, instead of using reduced to echelon form to solve matrix equation, we can use inverse equation. Not inverse equation, sorry. Matrix equation where you have AX equals B, so X is A inverse of B, like that. So that's why we need to know how to find inverse. For 2 by 2, our inverse is easy. All you have to do is take the determinant, which is the right diagonal minus left diagonal, and then you take the inverse of it, and then you divide. I mean, if you take inverse, then you have to multiply. You multiply your matrix by switching the position for A and D. So 1, 1, and 2, 2, they switch their position, the element, and then 1, 2, and 2, 1, they change their sign. So B and C, they change their sign, and A and D, they switch their position, and you multiply by 1 over the determinant. But for 3 by 3, finding the determinant is not so easy. It's not just right minus left diagonal. It is, but then you have 3 right diagonals, 3 left diagonals. So for 3 by 3 matrix, the determinant is you add all the right diagonals and you subtract all the left diagonals. And how do you find right and left? It's easy. All you have to do is repeat the first 2 columns next to the third column. So you have A, D, G, and B, E, H. If you rewrite the first 2 columns next to the third column, then you can have right diagonal number 1, right diagonal number 2, right diagonal number 3. So you take all 3 diagonals, you add them, and then you subtract. Did I do anything wrong? A, D, G, B, E, H? No, right?
The bottom right on the lower diagram says 8. And it also gives the
No, it's a typo because we have this one. Let me change the color. We have this, which is 1, 3, 2, 2, 3, 1. And then you're subtracting this, which is 1, 1, 2, 3, and then 3, 2. And lastly, this is 3, 3, yeah. So you're taking this one. So B is 1, 2, 1, 2. Then we have D is 2, 1, so 2, 1. And then you are multiplying the I, which is 3, 3.
The addition shows above it, the last addition.
Yes? This one could be typo because this 3 is here, not here. So what is this? The first right, the second right, the third right minus left. So this is right. So 1, 1, 2, 2, 3, 3, 2, 1, 2, 2, 3, and this is 3, 1, and then 3, 3, 1, 3, and 2, 1, and 8, 3, 2, not 3, 3, 3, 2. Oops. Three, 2. It doesn't work. Okay, 3, 2. That's it. So you take the right diagonal, you add them, and then you subtract all these left diagonal. This is your determinant. But this is not the only way of finding the determinant for 3 by 3. There is another method. It's called cofactor expansion method. Where what you do is you take one element from your row 1, and then you multiply the determinant of the, what do you call them? I forgot. So you take, let me erase, no, let me actually rewrite this. A, B, C, D, E, F, G, H, I. So we can find the determinant using this method. You take 1, 1, a 1, 1 position, and then you cross out everything else. So you're left with this 2 by 2 matrix. You multiply that A by this determinant of this 2 by 2 matrix. So position 1, 1, A1, position 1, 1 multiplied by the determinant of the 2 by 2 matrix, you left with if you cancel the first row and first column. So this is 1. Then you always have to subtract. So this one, the sign is very sensitive. You have to remember the sign. Where for the other one, you don't have to remember the sign. I mean, you have to remember the sign. You're subtracting the left diagonal. So here, first you start with A, and you don't take anything else on the row and column. You multiply the determinant of the other 2, and then you go to the B. So it cancel out. You take your B. As a result, it cannot take any of these. So, sorry, my bad, not this. Since you're taking B, so you're erasing the entire row 1 and column 2. So if you erase row 1 and column 2, you left with DH and G, so DF and GH. So you take the determinant of this 2 by 2 matrix, DH minus GF. So whatever you are taking from your row, you take the other 2 elements and take the determinant of that 2 by 2 matrix. If you go for C, that means you cannot take row 3, column 3 or first row. So you left with DEGH, and then this multiplied by the determinant of the 2 by 2 matrix. And the sign always alternate. The first one is always positive, second one is negative, then the next one is positive. And if you want to take any other row or any other column, you have to look for the sign. Do I have it here? No. So how signs work is this. The first one is multiply. You multiply the first one positive, second one you subtract, third one you add. And if you don't want to use the first row, if you want to use any other row, it's same thing. If you want to use the third column, the first one is positive, then negative, then positive. If you want to use the third column, so third row, same thing. You start with positive, negative, positive. Or if you want to take the column, not the row, no problem. Positive, negative, positive. And if you want to do in the middle, what side is supposed to have? Can you guess? Positive. So here, one bad thing is the sign is very important. You cannot mess up the sign. So here, this example is showing if you expand around first row, this is what you're supposed to have for your determinant. A times determinant of the other two column, not column, like two-by-two matrix, subtract B times the determinant of the other two-by-two matrix, plus C times determinant of the other two matrix. And you add and subtract whatever you get, that's the determinant. This is a normal method or professional method of finding determinant for 3x3 matrix. But if you are fine with the first method, you don't have to do that. So here, what do you call minor? It says if A is an n by a matrix, and Mij is n1, n minus 1 by n minus 1 means 2x2 matrix, then Mij is called the minor of Aij. And we define the cofactor of Aij as small aij. So this is basically what it's saying. You take, if you don't want to remember your sign, like the way I showed plus, minus, plus, if you cannot remember, then you don't have to remember, you have to remember this formula. This formula says -1 to the power, your row and column, the sum of the row and column. And then determinant of whatever you're taking. For example, let's do this one. It says we have a matrix, T/T matrix, the Ij minor of A denoted by Mij is the determinant of the matrix obtained from A by removing the ith row and j column. So whatever row and whatever column you are removing, whatever left, we call the minor. Okay, the minor. So let's say you want to find the determinant by expanding around this one. On the last example, we expanded around the first row. And if you want to do it around, actually second row looks weird. Let's do it first column. If you want to expand, no, let's do it this one. This one has a 0, which is a good thing. Let's say we want to find the determinant using this column, the third column. So how do you find it? What you do is first you take 0. 0 times. Now that 0, we have to remember, and if you don't remember this one, then you can use this one. It says -1 to the power, we have first row and then third column. So 1 plus 3. So -1, 1 plus 3. What is 1 plus 3? 4, right? What is -1 to the fourth power? Positive or negative? Positive. And see, we have a positive. So if you cannot remember your position, the sign for the position, you don't have to remember, you just add the row number and column number. So this is A13. Row 1, column 3. If you add 1 and 3, it's 4. -1 to the 4 is positive. So our sign will be positive here. So for 0, you erase this, erase that, and you have 1, 1 minus 3 times 5, which is 15. Plus, no, next one, okay, you can write plus, no problem. But then you have to write -1 to the second one is, the position is row 2, column 3. So 2 plus 3 is 5. -1 to the 5 is negative. So our answer will be negative here, which is true because we have already negative here. And then you multiply 2 times. So if you erase the 2, that means you have to erase this one. Whatever row and whatever column has the element you selected, you cannot use that row or that column. So you are removing row 2 and row column 3. What is left is 2 -1 on the first row, 5 1 on the third row. So you multiply by the determinant. 2 times 1 is 2, minus 5 times -1 is -5. So 2 plus 5.
Does it matter the order? So like, for example, for the first one, if I do A times 5G minus H hat, does that matter?
A times IE minus HF. This is the rule. So what do you want to do then?
So would it be fine if I switch, ID?
So you're saying FH minus IE?
No, I mean like in the multiplication, I guess there's multiplication.
You mean here?
No, I mean so the both letters. Like if I switch EI,
Oh,
and then IE.
I know. Multiplication power doesn't matter. 2 times 3 same as 3 times 2. The main thing is the subtraction. You cannot switch the position for the determinant. Okay. So next one you're multiplying by 2. Multiplying by 2 means the second row and column is ready. So we have 2 negative 1, 5, 1. So we have 2 times 1 is 2 minus 5 times negative 1 is negative 5. So that gives us positive 5. And then plus negative 1. Next, we are taking the third one, 6. The position for 6 is 3, 3. So 3 plus 3, which is 6. So you're going to have a plus sign here, and minus sign here. So for the 6th position, the third row cannot be used and third column cannot be used. So we left first row 2 negative 1, second row 1 3. So the determinant is 2 times 3 6 minus 1 times negative 1, which is positive 1. So this is 0 because 0 times anything is 0. And this is 2 times 7. And this is 6 times 7. So negative 14, positive 42. 12 minus 4 is 8. 3 minus 1 is 2. 28.
Question. When you have 2 times the quantity 2 plus 5, where did that, how is that not a negative? You had.
So if you did,
5, 1.
if you did 2, so this is gone, right?
Yeah.
So we have 2 times 1, which is 2, minus 5 times negative 1, which is negative 5.
Oh, because you do the minus.
Minus
goes
times
down.
minus times into plus.
Okay.
So you can use any row or any column, but you cannot change the element. You cannot do one element from row 1, one element from column 3. Like it doesn't work. You have to take straight row or straight column. Okay. This is not bad if you have zeros, more zeros in your matrix. For example, the next one is this. To see 20. This example is done by the expanding by first row. So if you use first row, this is what we have. And here I did third column, we got the same result. So it doesn't matter which row or which column you use, you're supposed to have the same answer. Right.
So if the row you're using is also the row that's multiplied.
Exactly. If you have the entire row is 0, then the determinant is 0, always. Or if you have identical rows, the determinant is 0.
So if you have one row or column that is also the determinant,
Automatically 0.
even if you do another row. Okay.
So this one we use when we have other types of matrices. For example, not here, something like this. When you have one column with 2 zeros or like this easier, we can do the expansion, the cofactor expansion method, and we can easily find the determinant here. But we are going to do that later. First, how about we have determinant for triangular matrix? Either left triangular or right triangular, doesn't matter. If we have triangular matrix, that means the determinant is the, what do you call it? The product of the element in a diagonal. The product of the elements in a diagonal. For example, here, this is a lower matrix, and we have the diagonals 2, 1, -2. So determinant for A, we don't need to do any hard math. it's automatically 2 times 1 times -2, which is -4. And why it's -4? Because our diagonal is a right diagonal. So for right diagonal, the answer stays same. But for left diagonal, it's minus of whatever you have. So you have to change the sign. For example, the next example. If you take the determinant for the next example, 0, 0, 3, 0, 4, 1, 2, 3, 1. This is also a lower matrix, but look at the diagonal. It's a left diagonal, not the right diagonal. For left diagonal, we always have to subtract. See left diagonal? We always need to subtract. The right diagonal, we always add. So right diagonal keeps its sign, but the left diagonal change its sign. So here our determinant will be negative of the product of 2 times 4 times 3, which is negative 8 times 3, 24. So a triangular matrix has a determinant of the diagonal only, and based on what type of diagonal you have, you work with the sign. For right diagonal, the sign stays. For left diagonal, sign changes. And if you can remember all these rules, no problem. You can use the other two methods you learned. Copy the first two column and then do the diagonal, right diagonal minus left diagonal. Or you can do by inspection. I mean, this one is done by inspection without doing any math, any hard math. So when do you use the inspection method? You look for good things. Do you have any good things? What good things I'm talking about? If you have any entire row or any entire column is 0, I mean, full of zeros, a determinant is automatically 0. You don't even have to show any work if you can remember this method. Or if you have triangular or diagonal matrix, a determinant is the product of the diagonal elements. If you have two identical rows or two identical columns with the same row twice or same column twice, the determinant is automatically 0. So for these two situations, for column or row full of 0, you don't have to show your work. If you have identical rows or identical column, you don't have to show your work. If you have triangular matrices or diagonal matrices, just multiply the diagonal entries. And then the last one is, what if we have not all zeros, 1, 0, or 2, 0, what do you do? If you have 1, 0, or 2, 0, you can simply do the cofactor expansion. So this one has the third column, 0, 0, 3. So if you expand around the third column, the first two element is already 0. That means you're not going to get any result from that. So the only thing you are going to use is the 3. If you want to use 3, that means you cannot use the third column or the third row. So you have to vanish third row and third column, and then you multiply 3 with the determinant of 2, 1, 4, 5. But you have to remember the position. If you cannot remember the position, then you have to do your -1 to the power 3, 3 plus 3. So if you do remember the position, you always start with positive. Positive, negative, positive, negative, positive. So 3 is a positive here. So positive 3, this one comes from the thing I'm talking about, the plus sign. And then the determinant of 2, 5, and 4, 1. So 10 minus 4 is 6. 3 times 6 is 18. So when you have more than 1, 0, or 2, 0 in a row or any of the column, it doesn't have to be third or the first. Even if you have in the middle, the second row or the second column, 2 zeros, you can expand around that row or that column. Your life will be easier. For example, this one. On the first row, we had 2 zeros. So we had 2, 0, 0, 4, 1, 3, 7, 3, -2. Since we have 2, 0, 0, So we are going to expand around the first row. As a result, we cannot use the first row or first column. So we erase that, and then we take the determinant of the other 2 by 2 matrix. So determinant is 2 times, and here our sign for the 2 is positive because this is the first position, 1 position. So we have 2 times -2, sorry, 1 times -2, which is -2, and you're subtracting 3 times 3, which is 9. So you have 2 times -11, which is -22. Again, I'm just showing you all the methods. Whatever is easier, stick with that. You don't have to follow a specific rule. It's up to you. What do you think is easier for you? Any question? Anybody is lost yet? No? Okay. Then I have a bunch of examples for you. Are you guys done copying this? Can I flip my page? Okay. Then I have 2 pages, 1, 2, 3, 4, 5, 6. 6 of these. Find the determinant. Oh, I should erase these answers. Otherwise, you lost interest. Find the determinant for all 7. 1, 2, 3, 4, 5, 6, 7 of these. Try them. It's our prayer time. I'm going to pray and then we'll do them together. You don't have to work alone. You can talk with your neighbors, exchange ideas.
Over a lecture, you said AX equals B is equivalent to AX hat equals B. What does that refer to?
Then X hat is of the variables.
Other
X1, X2, X3, X4.
okay.
These are the ones.
And then here you said if A has an inverse, then the system AX equals B has a unique solution. If there's no inverse, then there are two scenarios. Either something or
Either no solution or infinite solution.
or infinite. Okay, thank you.
Are you guys ready? Let me take the attendance first. Today is what? 22. 10:22. Brendan C. Not here. Joseph. Justin. Zibran. Shibu. Michelle. Jack. Not here. Ashif. Darius. Winston. Abigail. Shane. Emily. Pinar. Christine. Edison. Aisha not here. Brandon here. Elvin. Shafal. Alexander. Here. Shitila. Here. Wanshuan. And Kailun. Kailun, help me with the first one, please.
3, 4, 5, -6.
The determinant of A. 3 times 4 minus 2 times -6. So 12 and what? 12 plus 12, the answer is 24. Let's see. 12 and 12. Yeah, that is wrong here. It is positive 24, right, guys? Okay, Shitila, next one, B. So 20 plus.
Oh, minus.
20 minus 16. That's 4. Yep. Elvin. Good job. We don't need to do any math here because we already see we have the same two rows. So anytime you have same two rows or same two columns, it's automatically 0. Brandon. The next one. D. Zero times anything is 0. So you can ignore the zeros. So you're expanding around the row or the column, which one? Row. Okay. That means you cannot use the first row or the third column. So you have 3, determinant is 3, and then you multiply by what? 0 times 3 is 0. 4 times 3 is 8. So you have 3 times -8. But what's the position for the 3, plus or minus? This is plus. The next one is minus. And the next one is plus. So position for 3 is plus or minus? It's plus, right? The position is plus. But the answer is minus, but the position is plus. The first one is plus. The next one is minus. The next one is plus. So what's the sign for the position for 3? 3 has position 1, 3. 1 plus 3 is 4. So negative 1 to the 4 is plus. The sign for 3 has to be plus. And then the determinant gives you negative 8, which is negative 24. The sign of the position is very important. Luckily, here we have plus position. But for example, if you want to expand around this one, then 4 has a position minus, sorry, 4 has a position plus. Which one has a minus? Plus, minus, plus. Plus, minus, plus. Luckily, they all have plus. If you want to switch around, expand around any of the row or any of the column. Did you understand? Every sign, every position has its own sign. So to remember the sign. Shivu.
Sorry.
Huh? It's not what?
It's not like plus minus plus and then next row is minus plus minus.
So this one is plus, the next one is plus, the next one is minus, then this is plus, this is minus. No.
No.
This is minus, sorry. See, if you mess up one position, everything is wrong. So this is minus, this is plus. This is minus, this is plus. So this is minus, this is plus.
That's why I said minus.
But you're expanding around this position, not this 3.
Oh, I thought you were just asking in general, like, what does that agree? Like,
No,
Okay.
whatever you're expanding around, that position you have to remember. So when you're expanding around the position 3 on the first row, in first row, this 3 has a position plus. So plus 3 times the determinant of the minor, which is the other 2 by 2. Shivu?
I was gonna say that you can also do the diagonal.
Diagonal. Exactly, it's a diagonal also. See? It's a lower triangle, so all you have to do is multiply the diagonal. But if you multiply the diagonal, this is the left diagonal. So it's a minus of the left diagonal. So answer has to be minus. So see, 2 ways you can do that. Plus you can do the other one, copying the first 2 column and then do right minus left diagonals. Okay, let's see. Ashif, the next one. Negative 4. How did you figure that out? What did you do?
So it's the row for the cofactor.
Cofactor. So which row or which column you chose?
So I chose 2, the first cell on,
Here?
yeah, so that and to
So you cannot use this or cannot use that. So 2 times negative 2 plus 0, which is negative 4. So 2 times negative 2 is negative 4. This is one way of doing it. Another way, you can just look at the diagonal. This is a lower triangle. Lower triangular matrix. In lower triangular matrix, the diagonal is the product of the diagonal elements is the determinant. So 2 times 1 times negative 2 is negative 4. Great. The next one is interesting. Any volunteer? You already did one. Shibu. F.
I did it around like one did it.
So you have 1. Now it's the interesting one. What's the position for 1? I mean, the sign for the position 1. Minus. So see, this is what I was talking about. Plus, minus, plus. Since we are revolving or expanding around the second position, the second row, sorry, second column, it has a minus sign in the front. So -1 times, go ahead, Shibu,
And then
2 times 7,
minus
3 times 5, 15. So
-1.
-1 times -1 gives us +1. Let's see. Yep. It is +1. Cool, right? Who would like to do the last one? Find all values of x for which the determinant will be 0. So determinant is 0. You're finding Abigail, right? Go ahead, Abigail. 2 minus x, 3 minus x, minus 4 times 3. So this minus that. Good job. So you find the determinant, which is the right diagonal minus the left diagonal, and it says determinant is 0. And then what do you do?
It's, minus
Mm-hmm. 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 Perfect. Combine like terms. So we have 2 like terms here, 2 like terms there. Mm-hmm. Minus 6 equals 0. Factor. So which two numbers multiply to -6, combine to -5? -1 plus, no, 1 cannot be minus. The bigger factor has to get the middle sign. So if you want to use 6 and 1, your 6 has to be minus and your 1 has to be plus. -6 times 1 is -6. -6 minus 1 is -5. Right? So what do you get? X equals 6 and -1. Yep. That means we definitely don't want our x to be either 6 or -1 if you want to use that to solve for a system equation. We don't want determinant to be 0. When determinant is 0, it's non-single, it's singular, means bad. We don't want bad matrix. Oh, we forgot to ask you this question, talk about this question. Determine whether it's singular or non-singular. So for A, is it singular or non-singular? None. Non-singular. For B on the left page, singular or non-singular? Our determinant is 4. Non-singular. C, our determinant is 0. Singular. D, non-singular. E, non-singular. F, non-singular. And the last one is asking what makes it singular. We found it. Any question? Determinant is 0. If determinant is 0, it's singular, means it's bad. Determinant is not 0, it's not singular. It's good. Okay.
Does the diagonal products, does that only work for the lower triangular?
Lower or upper, any type of triangular, lower triangular, upper triangular, or diagonal matrix for anything. But you have to remember your position. If you're taking right diagonal, it's plus. If you're taking left diagonal, it's minus. But any type of triangular will work that. Any type of triangular will have the determinant is the product of the diagonal entries. Since we know what is determinant, that means we are ready to find the inverse. And we talked about in our last class, one of the easy method that is not formal. School teacher, they don't teach us this, but I found it online and it was really cool. So here what we do is first step, we find the determinant. So we learned so many methods to find the determinant. We find it by using any one of those methods. And then we need to find, we need to change our original matrix. How do you change it? What you have to do, you copy the first two columns next to the third column. And then you copy the first two row below the third row. So you copy many things here. Once you copy many things, then you erase the first row and first column. Once you erase the first row, first column, and then you take the determinant of every 2 by 2 matrices. The first one is EI minus HF. So EI minus HF. The next one is BI minus CH. So if you go find the determinant row wise or column wise, if you go column wise determinant to find the determinant, you have to write them down in a new matrix row wise. So here you find the determinants row wise, so column wise, but you write them row wise. Once you're done with the first two column, then you go to the next two column, the third column and the fourth column. And you do the same thing, take the determinant of every 2 by 2 matrix, go downward, go column wise, but write them row wise. Let's do one example. This one is a bad example. Can I change my slides? Or let me do it here actually, no problem. Let's say we have 1, 2, 3, 4, 5, 6, and 1, 2, 1. Okay, here's an example. 1, 2, 3, 4, 5, 6, 1, 2, 1. This is our original 3 by 3 matrix. We want to find the inverse of that. So step 1, write down the first two columns next to the third column. So 1, 4, 1, 2, 5, 2. Once you copy the first two column, now copy the first two row below the third row. So these two row, we are going to copy them down. 1, 2, 3, 1, 2, 4, 5, 6, 4, 5. So we copied first two row, first two column. Once you're done with copying everything, then you erase the first row and first column. So they are not needed anymore. We just erase them. And then we go find the new matrix. So we use determinant of 2 by 2. The first one is 5 times 1. 5 times 1, let me just write this down. 5 times 1 minus 6 times 2, which is 12. The next one is 2 times 3 minus 2 times 1. So 2 times 3 is 6 minus 2. 6 minus 2. I'm going row column wise when I'm finding the determinant, but I have to write them row wise when I write them down in a new matrix. Our last one is 2 times 6, 12, minus 3 times 5, 15. So we are done with the first two column, find the determinant of everything. Then you go to the next one. We do 6 times 1, 6, minus 4 times 1, 4. Then column wise, 1 times 1 is 1, minus 3 times 1 is 3. Next, the last one is 3 times 4 is 12, and you're subtracting 6 times 1, 6. So I'm finding the determinant column wise, but I'm writing them down row wise in a new matrix. The last column, 4 times 2, let me change the color, blue. 4 times 2 is 8, minus 5 times 1 is 5. Then we have 2 times 1, 2, minus 2 times 1, 2. Then we have 5 times 1, 5, minus 4 times 2, 8. So this is the new matrix. We need to multiply this new matrix by 1 over the determinant. That means you have to find the determinant. Let me find the determinant here. Insert passage. 1, 2, 3, 1, 2, 4, 5, 6, 4, 5, 1, 2, 1, 1, 2. So 1, 2, 3, 4, 5, 6, 1, 2, 1 was our original one. I copied the first two columns. To find the determinant, we go right diagonal minus left diagonal. So first right diagonal is 1 times 5 times 1. So this is the determinant, 5. The next diagonal is 2 times 6 times 1, which is 12. The last right diagonal is 3 times 4 times 2, which is 3 times 4 is 12. 12 times 2 is 24. 24. And now we are going to the left diagonal. Every left diagonal needs to be subtracted. So we are going to subtract. Let me change the color to red. Minus 5 times 1 times 3, which is 15. Minus the next diagonal, 1 times 6 times 2, which is 12. And the last one is 2 times 4 times 1, which is 8. So right diagonal addition, left diagonal subtraction. And you add all of this. 12 and 12 cancel out. What do you get? 515 is negative 10 plus 12 minus 16. 6. Correct? Is it correct, guys? Is my math correct? I think it's correct.
You copied the first two columns, but you left out the last two rows repeated.
We copy the row when you are finding the new matrix to multiply by the inverse of your determinant. So this is only for determinant. When you find the determinant, you only copy the two columns. But when you find the inverse, then you need to copy the column, also copy the rows.
Oh, okay.
So why do you need the determinant? The determinant needs to be multiplied by here to get the inverse. Our A inverse is 1 over determinant, and then this new matrix.
So last part you did was just finding the reciprocal. So, or I mean, sorry, the determinant of the frequency.
Which one? The original one, the right one. So we found our inverse. All you have to do is simplify. 5 minus 12 is negative 7. 6 minus 4 is 2. 8 minus 5 is 3. 6 minus 2 is 4. This is negative 2. This is 0. 12 minus 15 is negative 3. 12 minus 6 is 6. 5 minus 8 is negative 3. So I don't have space here. Let me write the inverse on the right page. A inverse is 1 over 6 times negative 7, 2, 3, column wise. 4, negative 2, 0, column wise. Negative 3, 6, negative 3, column wise. This is the inverse. But if you want to use the inverse to solve, that means we need to multiply the 1/6 by everything. So our final answer is actually all of these are divisible by 6. Not divisible, divide by 6. This is what multiply by 1/6 means, divide by 6. So now all I have to do is simplify wherever is simplificable. The first one we cannot do anything, so we have, I don't have space. Let me write here. Final answer, final A inverse. Negative 7 over 6, not reducible. 4 over 6 is reducible. We get 2/3. -3/6 we get -half. Then the second row, 1/3, -1/3, 1/2, 0, -1/2. So this is the final result for A inverse. It takes a little bit long, but in the Excel, you have to find one of them. Not many, only one.
The other way was the Gaussian reduction with the identity.
You definitely need to use that for 4/4. For 3/3, we have options. Either you use this method or the cofactor expansion, which is same as what we did. You just have to memorize the position and determinant of what you're multiplying by or dividing by. I found the memorizing is harder to remember. So if you use the first method, it will be easier. But same thing, okay?
What is 1/?
Determinant of A. This is determinant of A.
You would do bit for something with the
Same thing, but here the position you have to remember plus, minus, plus, minus, plus. But if you use the other one, I don't think you have to remember the position. Because the sign automatically comes when you do that, when you find the determinant. So 2 methods. And then that's all we have in 2.1. Now, we're not doing it, but in our next class, the 2.2 is same as 2.1. The only new things we have in 2.1 is little bit theorem about matrices, determinant, and then 4/4. How do you find determinant for 4/4? This is the new two things we have in 2.2. Once you're done with this, then we are going to do, that's it. We are going to do homework on this. So don't leave, I have your exam. Friday, we are not going to meet. We are going to meet again next Monday. Okay, let me give you your exam. Edison. Darius. Gibran. Michelle. Shane. Alex. Alexander. Listen. Hey, Brandon C. Not here. Ashif. Hailun. Justine. Not here. Shafal. Jack. Not here. Kanar. Not here. Abigail. Wanchuan. Christine. Winston. Bibu. Shitila. Emily. Brendan. Joseph. Elvin.